Hey guys, Mr. T here, just doing a video to demonstrate part 1 of the Modelling Hypothermia and Dehydration Directed Investigation for Year 10 Mainstream Maths in 2024. So this is to show you how quickly you should be able to do part 1 if you actually sit down and do it, because some of you in the class need it to pass your Term 3 report. So the idea is that to show you that there's no excuses for this. So this is the task sheet. We're going to go through that together in the class. But the focus of today is to do part 1, because that is the first part of the calculations that you need to do in the maths. You can write your own introduction. You can see the example that you'll be provided for an idea of what to write without copying it. But what's most important is the mathematical calculations of part 1, because I want to see that to help your report out. So we'll go to part 1 here. I'll write a title for myself. Modeling hypothermia and dehydration. Mr. T example. Make it bigger because it's a title. Just make it fit. Okay, so you're going to do your own introduction. You will do with help from example. Mathematical calculations. And I'm demonstrating part 1. So, scroll down. Part 1. Choose a simple solid with your own dimensions and find its surface area and volume. This calculation must be shown as a model calculation in the main body of the report. So, choose a simple solid. Use either rectangular prism, triangular prism, cylinder, or sphere. I'm going to do a sphere. So this is just a note for you in this video, but I'm going to choose a sphere. Sphere. Insert. I'm going to use a 3D model. Not a sphere. Sphere. I'll just do the blue one. And to make it easy, I'll just make the radius I'll make it 2 centimeters. So make this full screen to help me. I don't know what shape format, that's it. Make it red, make it thicker, and insert a text box to say that that is 2 centimeters. Make the text no fill, so it's see-through. Red, text fill, no fill. Oh, that's the fill of the within the letter. How do I? There we go, 2 centimeters there. So what are you supposed to do? Do a model calculation for the surface area and group these. Wrap text. Can't seem to wrap the text. There we go. Surface area equals 4 times by pi, insert symbols. Where's pi? 4 times by pi times by radius squared. So I'm showing the full calculation here. So it's 4 times by Control-C, Control-V, times by pi times by 2 squared equals calculated time. Exponent first, 2 squared is 4 times by pi equals times by 4, 50.27, 50.27 square centimeters is the surface area. Volume which is a simple solid. So this, what I'm doing here is letter A, find surface area and volume of simple solid. Undo automatic numbering. Surface area volume. Volume is 4 4/3 times by pi times by radius to the power of 3 equals 4/3 times by pi times by, what was the radius? It was 2 to the power of 3. Calculator time. 2 to the power of 3 is 8 times by pi is 25.13 times by 4/3, so I times it by 4 and divide the answer by 3. That gives me volume 33.51 and its volume, so centimeters cubed. So I've just done part A. B, find surface area and volume of simple solid with its dimensions doubled, which is a scale factor of 2. So you can draw a diagram of that too. I'm going to put these in bold to make the questions stick out. So I'm going to copy this. I'm going to change that to 4 centimeters because I'm doubling the dimensions. I've already done these calculations here, so you might as well. Copy and paste it, but change the radius to 4 now. To 4 now. These will be different. Four cubed. So now let's find the surface area. 4 squared times by pi times by 4, 201.06 to 1.06, and I forgot to say that I rounded this to 2 decimal points. Same with this, rounded to 2 decimal points. Same with this, rounded to 2 decimal points. And this one is also going to be rounded to 2 decimal points. I haven't worked it out yet. So 4 to the power of 3 is 64 times by pi times by 4/3, so times by 4 and then divided by 3. 268.08. 268.08. So that is part B done. Make a prediction about how the surface area to volume ratio might change as the dimensions of the solid change. Predicting the relationship between surface area to volume and scale factor. State this prediction clearly. So what is the surface area to volume ratio? Well, the surface area to volume ratio, SA to V ratio, is simply the surface area divided by the volume. And for scale factor 1, it was 50.27 divided by 33.51. 50.27 divided by 33.51. That first scale factor surface area to volume ratio is 1.5, rounded 1.50, rounded to 2 decimal points. What's the surface area to volume ratio here? It is 201.06 to 268.08. 201.06 divided by 268.08. 0.75. So what we notice is when it's the original, when it's the OG one, the surface area to volume, the surface area compared to the volume divided by the volume is 1.5. But when we double the size of everything, at the scale factor 2, it's 0.75, which is half of the original one. So this question here, C, is asking you to make a prediction. Make a prediction about how the SAV ratio might change as the scale factor goes up. You don't have to be right. You just need to state what you predict. So, because this halved, it went from 1.5 to 0.75, my prediction might be I predict that the SAV ratio will halve every time the scale factor goes up by 1. Because when it started at the OG and then the scale factor went up by 1 to scale factor 2, it halved. So I'm making a prediction that when it goes to scale factor 3, it'll halve again. I don't know if I'm right. I'm going to see if I'm right by doing the maths. So I've done C. D, apply the next 3 whole number scale factors to the original dimensions. So x3, x4, and x5. Find the surface area, volume of the solid each time. These repeated calculations may be put in the appendices. Okay, so you have a limited page limit. So these calculations are going to be a bit repetitive. So if you need space, you can put it into a section at the end of the assignment called the appendices, which doesn't take up your page limit. So what we're going to do is call this section calculations for scale factors 3, 4, and 5. Make it bold. So scale factor 3. Maths here. I can copy and paste the maths. It's going to be repeated, but it's going to be triple the size. So instead of that, it's going to be 6, and I don't know what the answer is here yet. This is going to be 6, and I don't know what the answer is yet. Don't know what these numbers are going to be. Leave it blank. Do the same thing again, copy and paste it, but I know I'm going to do it for scale factor 4. So it's going to be 8. Haven't done the maths, I'm just setting up the maths here. And scale factor 5 going to be 10 and 10. So now let's do the maths. 6 squared, 36 times by pi times by 4, 452.39. 452.39. Volume, it's 6 now, 6 to the power of 3 times by pi times by 4 over 3, so divide it by 3. 904. 904.78. What's the surface area to volume ratio going to be? 452.39 divided by 904.78. 452.39 divided by 904.78 is 0.5. That's the surface area to volume ratio there. So my prediction has already been proven wrong because 0.5 is not half of 0.75, but that doesn't matter. You're just asked to make a prediction. Now move on to scale factor 4. 8 squared, 64 times by pi times by 4. 804.25. Volume 8 cubed is 512 times by pi times by 4/3, so times by 4, and then divide the answer by 3, and you get 2144.66. 2144.66. Surface area to volume ratio 804. 804.25 divided by 2144.66. 804.25 divided by 2144.66. 0.38 to 2 decimal points. Last one, scale factor 5. 10 squared. It's 100 times by pi times by 4. 1256.63. 64 to 2 decimal points. 10 to the power of 3 times by pi times by 4 over 3. 4188.79. Do the division. 1256.64 divided by 4188.79. 256.64 divided by 4188.79. 0.3 to 2 decimal points. 0.30 to 2 decimal points. So I've just done D here. You can see that's quite repetitive there. Now, what I'm going to do is just do the assignment without putting anything in the appendices. And when you're doing it, if you find that you're going to go past the 8-page limit, you could cut and paste this into the appendices, okay? So I've done D, now we'll do E. Enter the data obtained in a table like below. So we have 1, 2, 3, 4, 5, 6. That table needs to go up to the scale factor of 5. So 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5. Oh, 6 by 6. I need a 6 by 6 table. 6 by 6. Scale factor, surface area, volume, SA to V ratio, change in SAV ratio from previous, and percent change in SAV from previous. You have half of this information already, you just typed it all out. What was the surface area at scale factor 1? to a 1.06. The volume was 268.08. So there's a lot of copy and pasting here. Oh, sorry, that was scale factor 2. My bad. Cut. That's in scale factor 2. Scale factor 1 was 50.27. And 33.51. Also, I forgot to put the surface area to volume ratio that I worked out. The surface area to volume ratio was 1.50. Scale factor 2 was 0.75. Scale factor 3, 452.39. Volume 904.78. The ratio was 0.5. 804.25. 2144.66. Scale factor SAV ratio 0.38. 1256.64. 4188.79. And the SAV ratio 0.3. So you can see the table is pretty much full. What is the change in SAV ratio from previous? So the way that you fill this out is you need to work out the difference between this to the previous number. So it's a subtraction. So the first one, there is no previous to the first one, so you just put a dash. But now I go 0.75 minus 1.5. That was a negative 0.75 change. Now for this one, I go 0.5 minus 0.75 because that was the previous SAV ratio. So 0.5 minus 0.75, negative 0.25. Next one, 0.38, take away 0.5. 0.38, take 0.5. Negative 0.12, and then the last one is going to be 0.3, take 0.38. 0.3, take 0.38. Negative 0.08. This last column is a little tricky because you need to find percentages. What is the percent change in SAV from previous? So what you're doing is getting this number here, the change, dividing it by the number up and left of it, and then timesing the answer by 100% to get the percentage change. So I'll do the maths here. Scale factor 2, percent change, maths, is going to be negative 0.75 divided by 1.5, and then times the whole answer by 100%. Negatives, well, I don't need it to be negative. I can change it to negative myself. 0.75 divided by 1.5 times by 100. That's going to be a negative 50% change. SF3% change. That's going to be negative 0.25 divided by the number up left of it, which is 0.75 times by 100%. Got a message. 0.25 divided by 0.75 times by 100. It's going to be a negative 33.33% change. That's to 2 decimal points. Next one, 0.12 divided by 0.5. SF4% change, negative 0.12. Oh, I didn't do the colon, I need to be consistent. Divided by 0. Up to the left, 0.5. times by 100% equals 12 divided by 0.5 times by 100. That's going to be negative 24%. Last one, SF5 percent change, negative 0.08 divided by number up to the left, 0.38 times by 100% equals 0.08 divided by 0.38 times by 100. That's going to be negative 21%, 21.05% to 2 decimal points. That's that done. Draw a bivariate scatter plot of scale factor along the x-axis and the surface area to volume ratio on the y-axis. You need Excel for this, and you all have Excel for free through EdPass. So I want scale factor, which is 1 to 5, and the SAV ratio. So scale factor, SAV ratio, 1, 2, 3, 4, 5. The SAV ratio, let's see if I can copy and paste this into here. Oh wow, yes I can. And you want to do a bivariate plot, which is a scatter plot of the scale factor on the x-axis and the surface area to volume ratio on the y-axis. So how do we do that? Select, I'll zoom in, select that, go insert, full screen up, insert recommended charts. You want a scatter plot here. Insert chart, XY scatter. And there is your bivariate plot. Okay. Want to edit this. You want to put labels properly. So format. How do we do the chart design? Add chart element. Axis titles, primary, horizontal. What was along the bottom? That was the scale factor. And add chart element. Primary vertical. That was SAV ratio. Make it a little bigger so our labels aren't all overlapping. Yep, chart done. So what is it asking? Draw a bivariate plot, surface area to volume ratio and scale factor. That is F. So we've just done E. E was table of scale factor and SAV ratio. That's what you were doing there. That's what the task sheet asks you to do. F. What am I pressing? Scatter plot of scale factor and SAV ratio. Be consistent with the... So I've drawn that scatter plot. Control C, Control V. Pasted. That is F done. G, analyze the results of your calculations in the table in part D and the graph drawn in part E according to the guidelines below. So I'm not going to do this because then you're just going to copy what I said. Analyzing the table and graph for part 1. You need to use these guidelines, these dot points about what to talk about. You can do it in order, I don't mind. Okay, what do you notice about the surface area as the dimensions are increased by a particular scale factor? Is there a relationship between the surface area and the scale factor applied? What's happening in the surface area? That's 4 times the size. This is slightly over double. This is less than double the 452. This is less than double. So the surface area is getting bigger, but the amount that it gets bigger is getting less and less over time. You could type that out. What do you notice about the volume? Do the similar analysis. What can you see is happening to the volume as the scale factor increases? It looks like it's getting bigger faster. What do the results show about the relationship between an SAV ratio and its size in general? So when the scale factor of something is small, like the original size, it had a big surface area to volume ratio, 1.5. But as it got bigger, the surface area to volume ratio halved. Then it got bigger again. It didn't halve again, but it still got smaller. Got bigger again, smaller, but the amount that this ratio is going down is getting smaller and smaller all the time. Okay, that's something to talk about here. Do these results reasonably explain why children are more susceptible to hypothermia and dehydration in hot cars? Well, as you can see from this graph, as you get bigger in size, the bigger scale factor ratio, what's happening to the comparison between your surface area, how much skin you got, and your volume? Well, here you've got a lot of surface area compared to your volume. Here you've got less, but it's spiked down a lot. Here you've got less surface area compared to your volume, less and less again, so it flattens out. So what's that saying is as you get larger in size, the amount of skin or surface area you've got compared to your volume is getting less and less. That's why it's flattening out. So that might explain why kids are really susceptible to hypothermia and dehydration, because they've got a lot of skin for the amount of volume or space in their body, okay? And then last question here, does your selected single solid properly model a scenario to be investigated? Why or why not? Well, this doesn't really look like a baby, okay? So that's what part 2 is about. In part 2, you're designing the shape of a baby. You're going to draw it up, and then you're going to do literally the same thing, all of this same maths, but for a more complex shape to see if this relationship stays the same. Okay? So that is a demonstration of part 1. For your drafts to help you with your term 3 report, you need to finish this part 1 and draw a diagram of your baby shape with dimensions, but that's it. You don't need to have done the maths. And that is well on the way to passing, so I'll be able to include that in your report if you're in that situation. Otherwise, this video just helps people with this assignment because I've literally done part 1 for you in, I don't remember how long that took. Was it half an hour or something? Something like that. Okay, so hopefully that helps you out, and I'll see you in the next video.